7, Unit 7, Lesson 7, Part 1. Independent and dependent events. Part 2 will be coming later, and it will have a worksheet with it. This one does have a worksheet as well, but it's just work along with. It will be attached in Canvas. First, with independent and dependent events, let's look first at the definitions of these. Now, independent is an adjective. It's free from outside control, not depending on another's authority. And it gives a couple of examples there. If it's a country, it's self-governing. If it means not belonging to or supported by a political party. Anyway, free from outside control. Next, not depending on another for livelihood or sustenance. 3, capable of thinking or acting for oneself. Number 4, not connected with another or with each other. I think that might be the best definition dealing with probability for independent, is not connected. So I'm going to write that up here. We'll talk about what that means here in just a sec. Now let's look at dependent. This is the definition I pulled out of my Apple Searchlight, so it's just, the Apple dictionary. So dependent means contingent on or determined by, unable to do without. In fact, another thing to think about with independent and dependent is, as far as the government is concerned with taxes, independent people file their own taxes. Dependents get claimed on somebody else's taxes. An independent person is free from outside. Well, they're not completely free. They're not dependent on another. Everyone has some sort of dependence on something. But anyway, the main thing about dependent is determined by something else. Now, we're talking about events here. Let's think about probabilistic events like flipping a coin. If I flip a coin and then I flip the coin again, if I flip a coin and then I flip that same coin again, these are two different events. It may be the same coin, but let's talk about whether it's independent or dependent. First, not connected. Are these two coin flips not connected? Does the outcome of one coin flip affect the other coin flip? Or is one of these coin flips determined by or restricted by the flip of the other coin? All right, if you flip a coin, you'll get heads or tails. You pick that coin up and you flip it again, you'll get heads or tails. And it doesn't matter what you got the first time. It's independent. It will not affect the other thing. Okay, that's a good example of independent. So a coin flip followed by another coin flip would be independent. Okay, consider the following. Let's say that I have a jar with candy in it, and there's all different kinds of colors of candy. There's some red, let's say that there's Skittles, some red Skittles, some purple Skittles, some green Skittles, etc. And I pick one out. Well, let's say I pick out a red Skittle and then I eat it. The probability of picking a red Skittle out of there would have been the number of red Skittles divided by the total number of Skittles. Now, since I took that Skittle out and did not put it back, the next time I pick, my probability of getting a red Skittle has now changed. There's one less red Skittle and there's one less Skittle, giving me different probabilities. So we're going to run through the examples on the worksheet here. This should give you a lot of good ideas on what independent and dependent is based on going over a lot of examples. Now, I recommend that you pause the video and try these out on your own, just thinking through them before you hear my answer. That will help you learn at a greater level. So determine whether the following events are dependent or independent and explain. You roll a number cube twice. At first you roll a 3, and then the second time you roll an odd number. All right. When you roll a number cube, does it change depending on what you got the first time? Well, I got a 3, but that does not change what happens on the next roll. So this is independent. And the reason is the cube doesn't change based on rolling a 3. So because the number cube doesn't change, the second roll is independent of what happened the first time. Okay, let's look at number 2. You flip a coin twice. The first flip is heads and the second flip is tails. Okay, so I'm flipping a coin. If I flip heads the first time, does that affect me being able to flip tails the second time? That has absolutely no effect. So this is independent as well. The coin is not changed by the outcome of the first event. It does not matter what happens the first time, it's still a 50-50 chance the second time. By the way, we'll be calculating the probability of things like this. If I flip heads and then flip tails, that's a 1 in 4 chance. Because if you think about the sample space, getting a head and then tails happens 1 out of 4 on the sample space. You randomly draw a marble from a bag containing 3 red marbles, 5 blue marbles. You keep the marble and then draw a second marble. Okay, we got to think about this one for a moment. There are 3 red marbles and 5 blue marbles. Let's see, you randomly draw a marble. You keep the first marble and then draw a second marble. So it doesn't say what marble you pick. Let's say that I ended up picking a red one. Now there are those marbles left in the bag. So the bag the first time had red, 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 blue, 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 blue. And when I picked a red, I had this as the outcome. Now, I very well could have picked a blue the first time, in which case the bag would now look like this. And when I get to the bag the second time, what happens in the bag the second time is dependent on what happened the first time. Because if I had picked a red, I would have this bag for the second time. If I picked a blue, I would have this bag for the second time. So the second probability is affected by what happens the first time because we keep the marble. So this is dependent. The first marble picked affects what is in the bag for the second pick. I'm going to shrink that down a little, get it to fit. Yeah, it's dependent because the first marble picked affects what is in the bag for the second pick. And hopefully that graphic below helps you see that. Okay, I'm going to move that off to the bottom. I might talk about it again. You randomly draw a marble from a bag containing 6 red marbles and 2 blue marbles. You put the marble back and pick a second marble. So this time there are 6 red marbles and only 2 blue marbles. Now, if you pick a red one, it doesn't matter, you put it back. If you pick a blue one, it doesn't matter, you put it back. So it does not matter what you picked the first time because you put it back. What is in the bag the second time is not affected. Therefore, it is independent. The first marble does not change the contents of the bag for the for the second pick. Therefore, it's independent. The first one was dependent because what you got the first time affected what was even available the second time. Number 5, you spin a spinner twice. You spin a 2, then you spin an odd number. Okay. We don't know what the spinner looks like, but spinners, they just have different sections. Evidently, these sections have numbers on them. And when I spin the 2, that's great. Is there anything about spinning the 2 that's going to affect the spinner for the second spin? No, there's not. This is independent. The spins don't affect each other. Okay. 6. Your committee is voting for a leadership team. First vote, you vote for president. Second vote, you vote for vice president. All right, I want you to think about this one. Does the person who's picked for president affect who gets picked for vice president? Now let's consider this. Let's say we have Jeff, Kyle, Mike, and actually Jeff, Kyle, Lucy, and Michelle. Okay, so for the first pick, we pick a president. Now, depending on who we picked, let's see if there's any difference here. I guess there could be up to 4 different options here, actually. There actually end up being 4 options. Let me go ahead and go through all of those. So, if for the first pick, you pick Jeff, Jeff is no longer available as vice president. If, let's say, the first time you picked Kyle, Kyle is no longer available for the vice president. If you picked Lucy, Lucy's no longer available for vice president. And if you picked Michelle, Michelle is no longer available for vice president. So the person you pick for president is not available to be vice president. And depending on who it was, it changes who is available for vice president. So this is definitely dependent. The person picked as the president will not be available for vice president. So definitely a dependent event there. 7. You randomly draw a tile from a bag containing of 20 game tiles. You keep the tile and then draw a second tile. The first tile says move 3 spaces. The second tile says skip a turn. Okay. All right, let's consider this. So if there's 20 game tiles, you pick one, and if you keep it, there's only 19 game tiles left. Because of that, you don't... let me think about this. When you do the second draw, the 19 tiles you have left depends on what you picked the first time. So this is definitely dependent. The first tile is not available for the second pick. Okay, number 8. You randomly draw a tile from a bag of 20 tiles. You put the tile back and then draw a second tile. Okay, on this one, it does not matter what I picked the first time. The second draw will have exactly the same probabilities because there are the same 20 tiles. It does not matter what tile was picked. So this is independent. And it is the, well, let's say both tile picks are independent. Well, that's just restating the answer there. Both tile picks do not have an effect on the other. You throw a bowling ball at the pins. There are 10 pins standing for the first throw and 4 pins standing for the second throw. Okay, got to think about the game of bowling. So there's 10 pins generally. Just going to quickly try to draw an aerial view of them. It's not going to turn out well, but okay. So we've got 10 pins, kind of shown from the top here. And we're going to throw the ball, and there's 4 pins standing for the second throw. Now we're not sure which pins are standing. We're not told. It could be that our bowling ball knocks over these pins and gives us a nasty split. But that's not the only way it could happen. We also could have knocked over these pins and have that. Or this is not unlikely. So there's a lot of different ways it could happen. What you have, the 4 pins you have available for the second throw depends on what you knocked over. So this is definitely dependent. The pins available for, whoops, there's an L there. The pins available for the second roll, it's not a roll, the second throw, depend on the ones you knocked over. Okay, number 10. You roll a number cube twice. First you get an odd number and then you get a number less than 2. Okay, it's the same number cube, but what you get the first time does not have an effect on what can happen the second time, so it's independent. The first roll has no effect on the probabilities of the second roll. Number 11, you randomly pick a straw from a holder containing 15 red straws and 8 yellow straws. You put the straw back and then draw a second straw. Alright, here, because you put the straw back, you've got the same probabilities for the second straw. So this is independent. You put the straw back. And this makes it so that you'll have the same probabilities the second time. Number 12. You randomly pick a straw from a holder containing 15 red straws and 8 yellow straws. You keep the straw and then draw a second straw. First you pick a yellow straw and then you pick a red straw. Alright, this one is dependent because you keep the straw. And this changes the probabilities for the second pick. Basically, you put things back, generally it's independent. You keep things and it's generally dependent. In the board game Monopoly, you roll 2 dice on your turn. If you roll a double, you roll again. If you roll 3 doubles in a row, you go to jail. So for your first roll, you got double 2s, then you got double 5s, then you got double 4s. Are these independent or dependent events? All right. I want you to think about this one, because this one you might get wrong. So let's think through this. The first roll, it happens it doesn't matter what happens with it. It just happens. You get double twos. Then because you got double twos, you're going to do the second roll. Now that second roll, it doesn't matter what I rolled the first time, does it? You have to think about that one. Then we get to the third roll. Okay, let's think about whether this is independent or dependent. If in the first roll we roll double twos, we do the second roll. Okay, great. What if we'd have rolled something else? If we would have rolled a 5 and a 3, we wouldn't have even rolled the second time. So it is possible that instead we would be done with our turn. So if you don't get doubles, you're done. And that would happen on the second time too. If we don't get doubles, then we're done. So, does the second roll depend on the first roll? It absolutely does. So this is dependent. You only roll another time if you get doubles. By the way, I recommend playing Monopoly or some other board game to help you pass the time and spend time with your family. It's good to do that. Number 14. 2 cards are drawn from a deck of cards numbered 1 through 10. You draw a 6 the first time, return the card to the deck, shuffle, and draw an 8 the second time. Alright, pay close attention to what happens between the events. We pick a 6, great. Now, since we put the 6 back, shuffle it, the deck is the same for the second draw, no matter what we picked the first time. So it's independent. The deck of cards is the same for the second draw, no matter what was picked the first time. So that is definitely independent. Okay, number 15. Tim takes 2 coins at random from 3 quarters, 5 dimes, 2 nickels in his pocket. One of the coins is a quarter and the other is a dime. Alright, so we've got 3 quarters, 5 dimes, and 2 nickels in the pocket. Okay, if you pick one of these, it will no longer be in your pocket. And it says that he's taking 2 coins at random. Now, it is impossible for him to take the same coin twice because he's taking the coins at the same time. So, if one of his coins is a dime, the other cannot also be this dime, and the probability for the second coin has to be limited to one of the others. Now, it could be that instead of the... actually, he didn't pick a dime, did he? He picked a quarter and then a dime. So maybe if he picks the quarter, the only thing available for the other picks are the other 2 quarters, the dimes, and the nickels. So what gets picked affects... What gets picked for the first coin affects what's available for the second coin. Now, even though these coins are being drawn at the same time, we can treat it as 2 separate events. We treat one of them as the first coin and one of them as the second coin, and it is definitely dependent. The one coin affects what the other coin can be. And this would be a little bit more obvious if, let's say, you only had 1 nickel. Because if you got a nickel, there's no way for you to get another nickel. So one coin does affect what the other coin can be. It doesn't affect what the other coin is, just what the other coin can be. Number 16. A number cube is rolled and a spinner is spun. The number cube. First you roll a 3 and then on the spinner you spin red. Okay, the number cube and the spinner. I don't see any way that what you get on the number cube is going to affect the spinner. They're 2 completely different objects. So I'm going with independent on this. Independent because the number cube and the spinner don't affect each other. They're completely independent objects. Okay, number 17. There are 20 people donating blood. Jill randomly asks 5 of the people their blood type. All right, now let's think about this. 5 people's blood type. Each person's blood type is independent of other people's blood type. So at first, this seems like it'll be independent. And as far as blood type goes, it is. But there are 20 people donating blood. Jill asks 5 of the people of their blood type. I'm pretty sure Jill's not asking the same person more than once. Jill's specifically asking 5 different people. So, if we have 20 people here, 5, 6, 7, 8, 9, 10, and let's double that. So if we have 20 people, I'll represent them as dots, and we ask them their blood type. So we go and pick this person right here, and they say, hey, I've got A positive. We pick this person over here. I'm also A positive. We pick this person over here. I'm AB negative. This person's B negative, and this person says they're O positive. So we have 5 people that we have asked, and we got their blood types. Now, after I picked the first person, there were only 19 people left to pick from. After picking the second person, there were only 18. So for the first pick, there were 20 to pick from. Second pick, only 19, then 18. 17 on the fourth pick, and only 16 left for the 5th pick. So, since it's 5 different people, this is dependent. The people, let's see, Jill has fewer people to pick from for the second, then third, etc. pick. So it's dependent because Jill has fewer people to pick from. Whoops. Oh yeah. Let's put the word from in there. I think that helps. Jill has fewer people to pick from for the second, then third, then fourth, then 5th picks. So it is dependent. The person that is picked affects who's left to be picked from. Now, if I just randomly pick somebody, each person's blood type, actually that's not completely true. Blood types aren't independent of each other. If you randomly select people, yes, but within the same family, blood types are not independent of each other. In fact, blood types depend on the genotype and phenotype of the parents, the biological parents. All right. Thank you for watching, and be prepared for another lesson tomorrow on compound probability. We'll be using this independent and dependent event stuff that we learned today.